Hi, Year 12. So today we're going through section 12.8, which is something called second order derivatives. Now, that's a really posh way of saying you just differentiate it and differentiate it again. This is dead easy today. Understanding what these things are for is the next section, and they are useful. They basically, is the second order derivative is written like this, d2y over dx squared. It basically means that if you start off with y equals 5x cubed, differentiate it, gives you dy by dx. That's your first derivative, or first order derivative, times by the power decreased to the power by 1. Differentiate this, and it gives you your second order derivative. Okay, and that's what we're going to be looking at today, just being able to differentiate it twice. Basically, what these things are for is the rate of change of the gradient. So it's looking at how the gradient changes at certain points on the graph. We'll talk about that in the next section anyway, because we can use it to decide things like, is a turning point in a graph a maximum or a minimum point? So for example, just very, very quickly, if you imagine this thing, that turning point there, that is a maximum. That is where the graph tops out and then comes back down. So the gradient goes from being positive to negative. So the change in the gradient at that point means it's actually negative. It's gone from being positive to negative, which means it's decreasing, which means the second order derivative will be negative and things like that. Whereas this point down here, this stationary point there, the gradient before it is negative, the gradient after it is positive, which means that at that point, the gradient, not the graph, the gradient is increasing at that point. And that's what we use second order derivatives for. But as I say, we won't need to do that today. We'll be looking at that tomorrow. Let's get the actual sort of process down. So, example 14. Given that y equals 3x to the power 5 plus 4 over x squared, find dy by dx. Now, hopefully, you've all spotted there that this thing is an issue because that's in the bottom of a fraction, so we don't like that. So we're going to have to write that out differently. So we're going to have to write that as y equals 3x to the 5 plus 4x to the minus 2, because now we can use the power. Remember, when you're doing differentiating, you are times by the power, decrease the power by 1. So dy by dx will be 15x to the power 4, excuse me, voice is going there, plus times by the power, it's going to give you minus 8, decrease the power by 1 to the minus 3. So that is your first order derivative, or first order differential, whatever you want to call it, dy by dx. So part B, figure out the second order derivative. So d2y by dx squared equals, just differentiate it again, times by the power, it's going to be 60x cubed, decrease the power by 1, times by the power, it's going to give me plus 24, decrease the power by 1 there to minus 4, and that's it. Okay. Example 15. When it's given in terms of f of x, you just put 2 dashes for the second order one. So again, we're going to have to do a little bit of manipulation here. So f of x will equal 3x to the power of a half plus a half x to the power minus a half. Notice there that the 2 in the half stays where it is. Okay, it's only the x that you can put back up there. I can't move that 2 to the top because that 2 has to stay there. It's a coefficient, it's a value. That's the variable, that's the letter, that's the thing that we can manipulate with these things. Right? So f dash of x then, times by the power, decrease the power by 1. So times by the power, it's going to give me 3 over 2. Decrease the power by 1, we'll go from a half down to minus a half. Times this one by the power, a half times minus a half is going to be minus a quarter. Decrease the power by 1 will be minus 3 over 2. Remember, if you're ever worried about doing these types of things, do them on the calculator, okay? So just to kind of show you, if we have minus 1 over 2, minus 1, we end up with minus 3 over 2, okay? Calculators are there so you never ever have to make silly mistakes like that. So please, please be careful with the fractions because it is something that people get wrong quite a lot. So differentiate it again to get your second order derivative, times by the power. 3 over 2 times minus 1 over 2 is going to be minus 3 over 4. Decrease the power by 1, minus a half, take away 1, we saw that before, it's going to be minus 3 over 2. This one times by the power, well, that's a minus times a minus, it's going to be a plus. 1 times 3 is 3, 4 times 2 is 8. And again, take away your power, let's do it on here, minus 3 over 2 minus 1 gives you minus 5 over 2. And that's it done. Okay. So differentiate it again. That's all you need to be able to do for these things. We will talk about what they're used for later on, but just being able to do that and understanding what it means, fine. Right, can you have a go then, please, at exercise 12H, and can you try actually, can you do all of exercise 12H? Okay. On question 2, basically, this is something that will come up next year in your mechanics. If you are given a expression or formula for the displacement, which is S, isn't it? So right in D4. If you differentiate it, you get the velocity. Because remember, distance, if that's the function for the distance, then if you differentiate that, the rate of change in the distance with respect to time, that's speed, isn't it? That's its velocity. If you differentiate that again, that gives you acceleration. Okay, so basically, if you get given the displacement, which is what you've got here, if you figure out your differential, first differential, that will give you the velocity. Figure out the second differential, that gives you your acceleration. Okay, so that's what you need to do there for that one. On this one, expand that first. So multiply out your 3 brackets, then differentiate it again. And on this one, remember with these things, in fact, what I'll do for question 4, I'll give you f dash of x. Okay, so for this thing, if I times by the power decrease the power by 1, it's going to give me 3px squared minus 6px plus 2x. Okay. So what you're going to do here is you are going to differentiate this thing again, exactly the same thing the way that I did, and you're told that when x equals 2, the second differential will equal minus 1. So sub in x equals 2, set the entire thing equal to minus 1, you'll be able to figure out what p is. Okay. Good luck, and any issues, let me know.